Hi to everyone. In this session, we have to discuss about hardness of water, types of hardness, and estimation of hardness by EDTA method. These are the topics to be discussed in this session. We have to see one by one. So, first one is hardness. Hardness, that means hard water. It means the water which does not produce lather with soap solution. Instead of that, it may form white scum. That is called as a hard water. So we can explain this here, why it is not producing lather with soap solution. The reason is the chemical formula for that soap solution is given here, sodium stearate. If you use this soap with water, then calcium present in that water can react with this soap and converts that sodium stearate into calcium stearate. So our objective of using soap solution is to remove that oily material from the cloth or fabrics. So that objective is that sodium stearate should react with that oil material present in that means hydrophobic part of the fabrics or some other material. Instead of that, what will happen? This sodium stearate reacts with the calcium 2 plus present in that water. So this purpose of sodium stearate is not occurring in this process. So we are adding the soap to remove that oil material, that means hydrophobic part of the fabric. Instead of that, the sodium stearate reacts with the calcium ion present in that water. So it will form a calcium stearate precipitate. So it is not forming any lather or a foam. So that is the main reason why that water is called as a hard water. So the sulfates and chlorides and bicarbonates of calcium and magnesium are the reason for this hardness. This presence of the salts gives hardness to that water. So this water gives wine red color with the areogram black tea indicator at pH 9 to 10. Next, types of hardness. So hardness can be expressed into two types. One is temporary hardness because of the bicarbonates present in that water. So bicarbonates of calcium and magnesium are the reason for this temporary hardness. So this hardness can be removed by simple boiling. If you heat that calcium bicarbonate, that will be converted into calcium carbonate. Similarly, magnesium bicarbonates are also converted into magnesium hydroxides. Both of these calcium carbonate and magnesium hydroxides are water insoluble. We can remove this by simple filtration. Next one is permanent hardness. This is due to presence of sulfates and chlorides of calcium and magnesium. So directly we cannot remove this by heating or some other. We have to treat these sulfates and chlorides with sodium carbonates, so that calcium and magnesium salts are converted into their carbonates. We can remove this carbonate by simple filtration method. So this is called as a permanent hardness or a non-carbonate hardness. So differences. So temporary hardness is due to presence of bicarbonates of calcium and magnesium, and permanent hardness is due to presence of chlorides, sulfates of the calcium and magnesium. So sometimes this temporary hardness can be called as a alkaline hardness, but permanent hardness is called as a non-alkaline hardness. So temporary hardness can be removed by boiling, but permanent hardness cannot be removed by boiling. Instead of that, treatment with the soda is needed. Units, that hardness can be expressed in ppm, that means 1 by 10 power 6. That means 1 part of calcium carbonate equivalent hardness in 10 power 6 parts of water. Degree French, in the air 1 part of calcium carbonate equivalent hardness per 70,000 parts of the water. Clark's degree, 1 part of calcium carbonate equivalent hardness per 10 power 5 parts of the water. Next, disadvantage of hard water. We are using water in domestic and industrial purpose. So while domestic purpose, this hard water is not suitable for washing. If you wash this with this water, then it may produce some precipitates and spots on the fabric cloth. So while bathing, it will form some scum on bathtubs and body. So it is not suitable for drinking. If you take this water as a drinking water, then it will produce calcium oxalate stones in our kidney or urinary tract. It becomes very dangerous to the health. And then cooking, if you use this water for cooking, then it may change the taste of the output food, and sometimes it may increase the fuel consumption. So these are the important disadvantages of hard water in the case of domestic purpose. In industry we are using water to generate steams. We are using boilers. In these boilers we are adding that water, that means we are feeding that water. After that we are heating that water. So while heating that steam will be generated, that steam can be used for some other purpose. So here problem is, if that water contains salts, then that consumption of fuel becomes more to heat that water. Next, sometimes that cracks will be formed. Scale and sludge is the important disadvantages of that water, hard water. If you use that in boiler, that can be explained in next session. So now we have to estimate the hardness. Estimation of hardness, that means that amount of calcium and magnesium salts present in the water has to be measured, has to be estimated. That is the estimation of hardness. For this, simple principle is given here. Here we are using EDTA as a complexing agent. EDTA means ethylene diamine tetraacetic acid. We are using disodium salts of EDTA. So we are using this EDTA with hot water. This EDTA will form complex with that calcium and magnesium ions present in that water. So amount of EDTA consumed in this reaction is equal to amount of calcium and magnesium ions present in that water. So from that titration we are calculating that ions, that means calcium magnesium salts present in that hot water. So this EDTA is insoluble in water, so we are using disodium salts of EDTA as a complexing agent. So that principle and simple method is given here. So we are taking ammonium chloride, ammonium hydroxide buffer, and then EBT as an indicator. So we have to take hot water sample. With that we have to add EBT as well as ammonium chloride and ammonium hydroxide. This is a basic buffer. Buffer can be used to maintain the pH at constant level. So now that hot water forms complex with EBT, that means wine red color. That means metal, that means magnesium or calcium ion present in that water can form a complex with EBT, that is wine red in color. After that we have to titrate with EDTA. So while titrating that EDTA metal complex will be formed. That means metal EBT complex will be decomposed. That EBT is removed from that complex, and this metal which is existing from here is now reacting with EDTA, and it will produce metal EDTA stable complex. So that EBT is blue in color. So now that endpoint is color change from wine red to blue. We have to take sharp endpoint here. We have to note down the consumption of EDTA in this titration. This is structure of metal EDTA complex. Here that oxygen and nitrogen ions present in this EDTA can form coordination bond with metals. This is called as a metal EDTA complex. So here color change is shown here. This is the metal EBT complex, and this is the metal EDTA complex with free EBT. Actually metal EDTA is colorless, so that EBT is blue in color. So after that EBT is coming out from that metal EBT complex, then it shows its original blue color. So now we have to discuss about procedure, how to do this. First one is standardization of EDTA solution. That means we have to find out EDTA, how much ml of EDTA is equal to how much calcium carbonate equivalent. That is very important. First we have to find out that. So we are taking EDTA in a burette. Then in flask, conical flask, we have to take standard hard water. That means that the hardness of water is already known. That water we have to take to standardize this EDTA. To find out the calcium carbonate equivalent, we need this standardization procedure. We are taking ammonium chloride, ammonium hydroxide buffer, and we are maintaining constant pH. So in this flask we have to add that EBT complex, EBT indicator, aerogram black tea indicator. Now that EBT indicator forms metal EBT complex, that is wine red in color. Next we have to start titration. We have to add that EDTA dropwise, and we have to rinse this flask immediately. After a particular time, that EBT metal complex will be decomposed and metal EDTA complex will be formed, and EBT is coming out from that metal EBT complex, and it forms blue color. that means color change from wine red to blue. So at that end point we have to note down the volume of EDTA consumed here, that is left as V1 ml. So we have to repeat this titration until that concordant value. Next, estimation of total hardness. So first we have to find out the both permanent and temporary hardness combinedly. We have to get that. That is called as a total hardness. So here we have to take sample water in a flask. Then we have to add EBT. Now that metal EBT complex will be formed. That is wine red color. Then we have to add that buffer also. Then only it will give metal EBT complex. That is wine red color complex. Then we have to iterate this, then color changes from wine red to blue. At the end point we have to note down the volume of EDTA consumed, so that the volume of EDTA consumed in this titration is V2 ml. Next one is estimation of permanent hardness. To find out the permanent hardness, we have to remove that temporary hardness. So to remove the temporary hardness, we have to take 250 ml of sample hot water in a flask. Then we have to heat that. We have to reduce that volume from 250 to 50 ml. Until that we have to boil that. So while boiling, these bicarbonates are converted into carbonates, then magnesium bicarbonates are converted into magnesium hydroxides, and these salts are water insoluble, and it will start to deposit at bottom of that flask. After a particular time we have to filter that. Then filtrate has to be taken for titration. So now that means that filtrate is free from temporary hardness. It is having only permanent hardness. That means that filtrate is now having only sulfates and chlorides only. There is no carbonates, bicarbonates. So now we have to take that in a conical flask. Then we have to add buffer solution. That means to maintain the pH stand. After that we have to add a few drops of EBT. Now EBT metal complex will be formed that gives wine red color. Now we have to titrate with EDTA. That wine red color is now converted into blue color as explained before. Now that volume of EDTA consumed in this titration is kept as V3 ml. So now coming for calculation. So first one is standardization calculation. So that already we know that 1 ml of standard hot water is equal to 1 mg of calcium carbonate. So 1 ml of EDTA is equal to 1 ml of standard hot water is equal to 1 milligram of calcium carbonate. Already we know that 1 ml of standard hot water is equal to 1 mg of calcium carbonate. So for that we have to calculate 20 ml of standard hot water is equal to 20 mg of calcium carbonate equivalent. So 20 mg of calcium carbonate equivalent equal to V1 ml of EDTA. So from this we have to calculate for 1 ml of EDTA, that means 20 by V1 mg of calcium carbonate equivalent. So now we have found that EDTA, that means calcium carbonate equivalents for 1 ml of EDTA we have calculated now. Then coming for total hardness, estimation of total hardness. So 20 ml of given hot water is equal to now V2 ml of EDTA. This is for second titration. So 20 ml of hot water is equal to V2 ml of EDTA. From that we have to calculate for 1 ml of EDTA. We know that 1 ml of EDTA 20 by V1 mg of calcium carbonate. So 20 ml of given hot water is equal to, so V2 into 20 by V1 mg of calcium carbonate. So from this we have to calculate for 1 ml of given hot water. That means 1 ml of sample hot water is equal to 20 by V1 into V2 by 20 into 1000. 20 will be cancelled, and V2 by V1 into 1000 mg per liter. Okay, this is total hardness. In 1 liter we are calculating. So next one is estimation of permanent hardness. To estimate that permanent hardness, we have to calculate like this. So now 1 ml of EDTA is equal to 20 by V1 mg of calcium carbonate. That is standard. So for V3 ml of EDTA, that means to find out that permanent hardness we have to do like this. V3 ml of EDTA is equal to 20 by V1 into V3 mg of calcium carbonate. So for 20 ml of sample water, 20 by V1 into V3 mg of calcium carbonate. So V3 by V1 into 1000 mg per liter of calcium carbonate. This is the permanent hardness. So finally we have to calculate for temporary hardness. we have to subtract that permanent hardness from total hardness. So V2 by V1 is total hardness minus permanent hardness is V3 by V1. So for 1 liter we have to multiply with 1000